Right, let's have a look a little bit deeper into this analytical geometry world, shall we? Essentially, and I, at the risk of repeating myself, which I do a lot, I know, what we've got to do here is you've got to make sure that you know your shapes, the properties of the shapes, okay? Geometry obviously relies on you knowing what a kite is and what the angles of a kite, parallelograms, trapeziums, even triangles, circles as well, right? Analytical geometry, this level and forward, is going to very much rely upon your knowledge of what happens. You've got to know, for example, well, you don't do it yet, but the tan chord theorems and things like that with circles. It's very important to know the shape. So the quicker you get into knowing those shapes and knowing the properties of the shapes, right? That is the secret of success here, right? The rest of it is really just a bit of arithmetic. It's not too critical. Let's just have a look here. Here they come up with a term. This is a new one, okay? And they come up with this term here called collinearity, okay? Prove that points are collinear, okay? What does it mean? What does collinear mean? Essentially, if we have got a line between A and B over here, right? And they give us the coordinates of A and they give us the coordinates of B, and they give us the coordinates of a point C. And then they're going to say that prove that point C, and we haven't given the coordinate, is collinear. Okay. Essentially what it means that if we plotted it accurately and we plotted point C, say it was there, it means that point C lies on the line between A and B. That's all that collinear means. Well, how do we do it? Well, it's actually quite simple. It's collinear. So let's have a look. First of all, let's go back to black. They've given the coordinates of A and B. Let's just have a look over here, all right? Let's say it's -2, -4. Okay, point A is -2, -4, and point B is 4 and 6, okay? I've chosen the third and the first quadrant here, and they've given us that prove that C is collinear, right? Never mind the coordinates of point C for the moment, all right? Let's just have a look. Essentially, just bear with me a second. I just want to have a look at this. Just look here. There's a point A and there's a point B. Okay? Now, if point C was not on that line, point C could be there or somewhere else, right? Which means that if we drew a line between this point C and A or another point C and A, then it means that where we are is we are going to be in a situation of the lines are not going to be on top of each other, are they? So what we're doing here is we're actually going to, let me just plug this guy in over here because it's shouting and screaming here for power. Okay, so let's just put it in. Right, what we're saying is we're now saying that to be collinear, okay, what we've got here is we've got to make sure that the gradients are the same, right? If the gradient is the same, then it means that it is collinear, doesn't it? Right? It means, sorry, God, let me just put that up there. There we go. Okay, so what do we do? Well, first of all, we say, right, let us look at the gradient of that line, MAB, right? That gives us the slope, doesn't it? Okay. The next step is we go ahead and we say, all right, what is the gradient of MAC? All right, or MAC up here. AC up there, let's say, right? If the gradients are the same, it means the slope is the same. And it means that point C is actually on the line because the gradient is the same. It's the same line that we're using, is it not? So let's go back to our problem here and we say, all right, let's have a look. First of all, let us find that gradient MAB. Let's look. Okay, well, we say, right, the gradient MAB is going to be MA to B. Remember, y2 minus y1 over x2 minus x1. So we're going to say it is 6 minus, and remember, why do I put it in brackets over there? So that the negative sign doesn't kick me into next week, right? And I work that out and I get 5 over 3. All right? Just, whoops, not make you look a little better than that. Oops. 5 divided by 3. Okay? Yes, we use brackets so that the negative sign doesn't boot us. It's critical to do that in every part of algebra, in every part of analytical, wherever we're dealing with things, trigonometry as well. You substitute in brackets. Okay? Right, so we've got that. Now they've told us that the coordinates of C are, let's go 1 and 1. All right? Well, let's see if this is collinear or not. M of AC is going to be equal to 1 minus 4 over 1 minus 2, okay, which is going to be equal to 1 plus 5 over 3. Therefore, the gradients are the same. Therefore, C is collinear. Okay, it is as straightforward as that, really. It's not a big deal. So whenever we're asked to prove that, then we can use that. Now, bear in mind, of course, just before we leave this collinearity thing, let's have a look. We can also have the reverse, right? Where they can say point C is collinear. So they could say A and B, for example, is there, right? And then they tell us point C is collinear, which means that point C is on this line here. Find the coordinates of C, right? How do we do it? Simple. You know MAB, let's just go back. MAB, okay, is known. Okay, let us say MAB is 2, just for argument's sake, right? Then you go and you say, right, green, you work out MAC using the x and the y coordinates, okay? And you put the gradients equal to each other, all right? And you'll be able to work out the x or the y coordinate, right? So if they tell you it's collinear, we just do it in reverse. It's as simple as that, okay? You just take the two gradients and put them equal to each other and solve for the one that you need. The other way, of course, you've noticed I've done it A to C. You also could do it from B to A, B to C. All right? You could also do it from, you could work out M, BA and put it, and look if it's equal. Well, ask, is it equal to MBC, right? And if it's equal, then it's collinear as well. I just work from A because conventionally we do work from A. Let us say the next question is, they say, what is the equation of the line AB? Okay, well, they've given us 2 points and they want to know the equation of that line. What do we do? Well, the first thing is we write down whenever we ask these, we write down the standard form. And this is y equals mx plus c because it's a straight line. Okay? So therefore, you can now write down the y coordinate you've got and the m you've got. So you can straight away write down, we've got over here m is 5/3, right? So we can say 6 is equal to m times minus 2, okay, plus c, we don't know. And we can also write down the other equation, minus 4 equals minus 2m plus c, and we put them underneath, okay, minus 2m, 6 equals 4m, silly me, sorry, 6 equals 4m, okay, plus c, minus 2m plus c, and we work it out, and you get that 10 is equal to, what I've done there is I've just subtracted, right? So 8 is going to be 6m, therefore m is equal to 5 over 3, and then back substitute to get c, and c is going to be equal to minus 2/3, if I'm correct, minus 2/3. Okay, I'm not going to go through that. That's quite straightforward, right? You can just back substitute in there to do it. So let's just have a look here, right? Now we've got that. So we know the equation of the line AB. Okay, y is equal to 5 over 3 x minus 2/3, all right? Now, let us say, for example, they want to find the equation of the straight line perpendicular to AB going through point C. So we're back on our previous example, just by the way. We're up here. Okay, let's have a look. What are they asking for? They're asking for this, aren't they? They're asking for that. They want to know the equation of this line. Okay? Now bear in mind that it is critical to draw this. Those of you who do physics with me know that I'm a stickler for please draw stuff. Okay? Because to try and keep in your mind what you're actually looking for is pointless. It's easier to have a diagram that says, right, oh, that's what I'm after. So we're looking for the equation of the line, right? Well, what do we know? Well, first of all, we know a point, okay? So let's see, what do we know? All right, okay. Okay, we know the line goes through point C, which is 1 and 1, right? We know it goes through there because we've already proved that it's collinear. Then we know, okay, the other thing we know is we know the gradient of the line over here, okay? We know the gradient MAB is equal to 5 over 3. Now, if the gradient of that line is 5 over 3, what is the gradient of the line perpendicular? What do? We say MAB multiplied by, and I'm going to change it to red, M of the perpendicular line, okay, I'm going to go back to normal, equals minus 1. Right? Therefore, 5 over 3 times M perpendicular is minus 1. Therefore, M of the perpendicular is minus 3 over 5. All right? Therefore, we now know that y, now this is the new line, perpendicular. We say y is equal to mx plus c as well, is going to be minus 3 over 5, x plus c. And how do we find out c? Given 0.11, x, y. Back substitute the x and the y's and work out c. And we find that c is equal to, let's just do it. We say 1 is equal to minus 3 over 5 times 1 plus c. Therefore, c is going to be equal to 8 over 5. And my line is y is equal to minus 3 over 5x plus 8 over 5. Okay? So what have we got here? We've got now a situation where we can tell, let's just get another page. We've got the equation of the line perpendicular. It's always, you can always be given that it's going to be the two gradients times each other, or the two gradients are going to be the same if it's parallel. Remember that situation? So in these things here, that's what you've got to know. And remember, you're going to be given a point that it goes through, and we just back substitute in to find it. Okay? So this is the type of question that we're going to be asked. Okay? Now, here they give us another one, all right? Let's just say they give us 4 points, all right? They might give it to you as just points, A, B, C, D, the coordinates, all right? They could give it like this. Point A, 0 and 3. Point B, 3 and 1. Point C, let me just put that like that. Point C, -1, -3. And point D is -4, -1. And they say A, B, C, D is a parallelogram. Okay? Find the coordinates of D. So let's say they perhaps didn't give us this in the beginning. Okay? Okay? But they've told us it's a parallelogram. Okay? Which means, right, what are the principles of a parallelogram? Well, the first thing, before we do that, let's make, as I've said before, make a sketch. Okay? So, let me just put this over here. Okay? So I just want to get that a bit tidier. So I've said 1, 2, 3. So let's put in point A. Point A is over there, 0 and 3. Point B is 3 and 1. 1, 2, 3 and 1. Point B is there, 3 and 1. Okay? And point C is -1, -3. So let's put it over there. So you are point C, -1, -3. And we know, now what you do is you take your pencil. Okay? And you know they've told us that it's a parallelogram, haven't they? Okay? So you've got a line doing this, right? And if it's a parallelogram, it must do something like that, right? Well, what are the key things of a parallelogram? Well, first of all, the sides are parallel. If the sides are parallel, it means the gradients must be the same. So you know that point D is somewhere over here, don't you? X and Y. It doesn't matter if you don't know. Okay, it's not too serious. It's going to pop out the wash anyway. But it's always useful to draw it. Can you see? I don't think they're going to give you numbers like -28 and +45, all right? If they do, okay, so be it. But generally speaking, they give you numbers that you can plot with a little bit of accuracy. No, we don't sit there with a ruler and measure it off. Like I've said, just use the lines on your paper to give you a more or less idea, okay? It helps a huge amount to just focus on where this point D is, right? Now, what are the main things? Well, first of all, you can say, obviously, this is going to be parallel, isn't it? Over there. And this guy is going to be parallel to that one. Okay? And angles, but we don't have angles, etc. Well, the key thing here, and this is, I'm going to actually do it in red. If it's a parallelogram, NB, parallelogram, diagonals bisect each other. Please note, remember that little thing. If it's a given a parallelogram, the diagonals bisect each other, which means they cut each other in half. Okay? Which means, how do we find D? Well, we say to ourselves, right, therefore what we're saying here is that the line between there and there, those are the two diagonals. It means this is equal to that, right? Okay? So what you do is they've each got a common midpoint. Yes, you can do this with y equals mx plus c's, gradients, etc., and work out a point of intersection. Of course you can. This is just a quicker way of doing it. That's all, right? So what we do here is we say, okay, it's got a common midpoint. Remember we did this one before? All right? Let's just scoot it up a bit over there. So what do? What is our modus operandi? We say, okay, find out the midpoint between the two known vertices. In other words, we know A and we know C, right? So if we know A and C, we first of all find midpoint AC. So we say X midpoint and Y midpoint, okay? And we put in our coordinates of 0 plus minus 1 over 2, which is going to be minus a half, okay? And Y midpoint is going to be 3 plus minus 3 over 2 is equal to 0. Therefore, the coordinates are going to be minus a half and 0. And you can sort of see on the sketch over there, can't you, that that's about right, okay? So if you got something like weird, like 4 and 0, you could see it's not possible and you can go back to it, okay? A lot of this maths work is self-correcting, actually, if you look at it, isn't it? Okay, just if you take your time setting up the problem. Now, how do we find the coordinates of D? What do we do? Right, hang on. We now know that the midpoint there, let me call that E, okay, as the midpoint. I know the coordinates there are minus a half and 0. I know I'm writing a bit small in there. Please excuse me. Okay, so I can now go back to that other little trick that we learned. Remember? What did we say? We said if we know that point, A, B in this case, let's say, and we know a midpoint here, and we're looking for that one, we know that's equal, right? Because the midpoint. Therefore, we can work out the x and y of this one. Because x of the midpoint is equal to x1 plus x2 over 2. But hold on, we know that coordinate, we know x1, we want x2, right? That's a 2. Okay, so then what do? I go and I substitute into my little formula. I say, all right then, we know that, so we say minus a half, I'm doing x. Minus a half is equal to 3 plus x of d, let's say in this case, over 2. Therefore, x of d is going to be equal to minus 4. And we do the same. We say y midpoint is equal to y1 plus y2 over 2. And put in, what do we know? Do we know y of the midpoint? Yes, it's 0. There it is. It's up above, right? These are the two coordinates that we're feeding in here, right? So we say, okay, 0 is equal to y1, 1 plus y2 over 2. Therefore, y2 is equal to minus 1. Therefore, we know the coordinates are minus 4 and minus 1. So we go to our diagram and we put them in. Okay? Remember, you always put in what you've got. You say that this is minus 4 and minus 1. All right? Therefore, we've now answered that part of the question, okay? And then they say, well, what shape is it? All right. Well, once again, can you see? The question they're asking us here is, now that you've worked out what parallelogram, they say, what shape is it? All right. And what do? Okay. We now are going to go and we're going to say, right, how do I find out what shape? You've got to know your shapes pretty well. So essentially, you're going to go back to length. All right? And what I did is I said, okay, it looks like a rhombus. It's not a square, is it? If we look at it, okay? All right? Looks like it could be a rhombus, okay? We're not too sure. We know it's not square, but let's have a look and see. Well, hang on. Let's just take the view and we go back and we say, all right. Let us work out some lengths, shall we? You go to lengths in these. Let's work out the diagonals bisect at 90 degrees. That tells us it's a rhombus. and one pair of adjacent sides is equal. Let's just have a look and see, all right? Let's have a look at the diagonals, okay? Let's find the m, the gradient, of the diagonals. Okay, find the gradient of the diagonals. Well, let's have a look. What is m of AC? Okay, that's our one diagonal, isn't it? Please stop these and go back and forth. I know it's not all sitting there in front of you, but you should have these down as sketches with you. Look at MAC, right? M of AC is the top piece down to the bottom piece. Remember, those are the two known ones anyway. We say m of AC is going to be equal to 3 minus 3 all over 0 minus 1 is going to be equal to 6 over 1, which is equal to 6. Now let's have a look at MBD. All right? Let's have a look at MBD. Okay? MBD, what would we say? All right? MBD, what we'd say for MBD is we'd say, yes, 1 minus 1 over 3 minus 4, which is going to be 2 over 7. Now, if they intersect at 90 degrees, it means that MAC times MBD must be equal to minus 1, because then it's going to be a rhombus. But you can see that that is not the case, therefore not a rhombus. Okay? You can see it's not a rhombus, you can see it's not a square, therefore it's just a normal parallelogram. All right? So when they're asking you for shapes, first of all, you can't assume, right? So you're going to go and look. If you worked out the lengths, for example, of AB, and you worked out the lengths of DC, you'll see the lengths are the same. All right? It's just a straightforward parallelogram, a rectangle that's been squished over to the side. All right? So yes, in analytical geometry, okay, and in the exam and the test prep, we'll do a few more of these from some old papers, but you've got to know your shapes. The actual formulas or the maths that you need here is only gradient of parallel lines is the same. So the m of this one must be equal to the m of that one, right? The gradient of two lines intersecting at 90, if it's 90, the gradient of this one multiplied by the gradient of that one is minus 1, right? So that's two huge things. Obviously, you've got to know how to get the y equals mx plus c out of it. But that in itself is really not a great deal of work. The key here comes to knowing, or rather to being able to recognize the shapes and the attributes of shapes. The key, diagonals bisect each other or bisect at 90 degrees for specific shapes. That's the key. Kite, you know that one bisected, not bisect, but intersect at 90 degrees. That's equal to that side on the kite, right? Those are key to analytical geometry. And please remember, analytical geometry is going to get big this year and next year and the year after. And it just gets more complex. So please put in a little bit of effort to know the attributes of shapes. What I say to my students is, you know, in your textbook, you get that whole page, which has got the shapes and the attributes. And it's also got the page of, if I know something, what do I have to do to prove it? Please make a copy of those, stick them up, and just before the exams, before the tests, just go through those all the time. That's the key way to do it. And of course, just do examples and more examples. Thanks for watching. The next one we're going to do is we're going to do financial maths, and then we'll be ending with statistics. See you in the next session, and learn those shapes. Cheers, bye.